Hi everyone. Today I would like to start part 1 magnetic materials. I am focusing the basic concepts and the concepts involved in magnetic materials. So here the basic concepts are what is meant by magnetic material and magnetic field intensity. Next one, magnetic flux density. And magnetization, magnetic susceptibility, next one, magnetic field intensity, magnetic flux density, magnetization, magnetic susceptibility, and what is magnetization, and finally magnetic permeability. These are the fundamental concepts in magnetic materials. So in addition to that, I am focusing what is origin of magnetic movement. Next one, classification of magnetic materials. Next, I want to focus hysteresis curve. Hysteresis curve or BH curve. And finally, hysteresis curve or BH curve. And finally, I am focusing soft and hard magnetic materials. So what I am saying, the basic concepts. So in part 1, the basic concepts are magnetic materials. What is meant by magnetic material? So here, magnetic field intensity, flux density, magnetization, magnetic susceptibility, magnetization, magnetic permeability, origin of magnetic movement, and classification of magnetic materials, hysteresis curve or BH curve, and finally soft and hard magnetic materials. So in the previous video already I have explained the basic fundamentals. What is meant by magnetic material? So what is magnetic material? Any material which can be magnetized is called magnetic material. Whereas coming to field, magnetic field intensity. So what is meant by field? The force experienced by unit north pole placed at the point is called magnetic field intensity. So what is the symbol for magnetic field intensity? H. And next one is magnetic flux density. Flux means the number of lines of force passing through unit area is called magnetic flux density. So which is denoted as B. So we can identify with B for magnetic flux density. And next one is magnetization. What is meant by magnetization? The process of converting non-magnetic substance into magnetic substance is called magnetization. And next one is susceptibility. How we can identify susceptibility? What is the formula for susceptibility? So susceptibility, J equals to M by H. The ratio of intensity of magnetization to the magnetic field intensity is called magnetic susceptibility. So next one is magnetization. Magnetization means already I have discussed the process of conversion of non-magnetic substance into magnetic substance. So which is denoted as M, magnetization. So next one is permeability, magnetic permeability. So what is the identification of permeability? Mu equals to B by H. Mu equals to B by H means the flux density, the ratio of flux density to the magnetic field intensity is called magnetic permeability. Okay, so everyone, already I have clear introduction has given in the previous video. So up to the fundamentals, magnetic permeability. So here now I am going to continue origin of magnetic movement. So here magnetic movement arises due to three concepts. First one is orbital magnetic movement due to electrons, spin magnetic movement due to electrons, and spin magnetic movement due to nucleus. Yes. So next one is origin of magnetic movement. Magnetic movement arises due to three basic concepts. Orbital magnetic movement due to electrons. Orbital magnetic movement due to electrons. Spin magnetic movement due to electrons. Next one, spin magnetic movement due to nucleus. So magnetic movement arises due to orbital magnetic movement due to electrons, spin magnetic movement due to electrons, and spin magnetic movement due to nucleus. So coming to first one, orbital magnetic movement due to electrons. So here mu equals to IA. So what is the area of cross section? A equals to pi r square. So here I E omega by 2 pi. So here pi gets cancelled. So here L means mu L. LH by 2 pi 1 by 2. Therefore mu orbital equals to LH by 4 pi m. This is called Bohr magneton. Mu B equals to EH by 4 pi m. This is called Bohr magneton. So what is the value of Bohr magneton? So by substituting E value and H Planck's constant, m mass of the particles, then we can get mu B equals to 9.24 into 10 power minus 27 ampere meter square. So this is the value for Bohr magneton. Mu B equals to 9.24 into 10 power minus 27. So similarly we can calculate spin magnetic movement due to nucleus, spin magnetic movement due to electrons. So second one, spin magnetic movement US equals to EH by 8 pi m. So the value of spin magnetic movement of electron 9.47 into 10 power minus 24 ampere meter square. So what is the difference? Here Bohr magneton 9.24 into 10 power minus 27. Here 9.4 into 10 power minus 24 ampere meter square. So what is the last one? Spin magnetic movement due to nucleus. Okay. So here we can substitute. We can get US value 5.05 into 10 power minus 27 ampere meter square. Spin magnetic movement due to nucleus. Next one is classification of magnetic materials. So depends upon the dipoles, magnetic materials can be divided into 5 types. First one, diamagnetic materials. Second one, paramagnetic materials. Third one, ferromagnetic materials. Fourth one, antiferromagnetic materials. And fifth one, ferrimagnetic materials. Friends, today I am going to teach about classification of magnetic materials. So due to the dipoles, magnetic materials can be divided into 5 types: diamagnetic materials, paramagnetic materials, ferromagnetic materials, antiferromagnetic materials, and ferrimagnetic materials. So here you have to concentrate first 3 magnetic materials: dia, para, and ferro. So first one, diamagnetic materials. Diamagnetic materials. The materials which have no permanent dipoles are called diamagnetic materials. So in diamagnetic materials there were no permanent dipoles. When diamagnetic materials placed inside the magnetic field, all the dipoles, all the lines of force are expelled from each other. Expelled from each other. So which obeys the susceptibility. Susceptibility is negative. The magnetic susceptibility is negative, small and negative for diamagnetic materials. So the examples are germanium, silicon, diamond are the examples of diamagnetic materials. Next one, second one, paramagnetic materials. So what is meant by paramagnetic materials? The materials which have permanent dipoles, but there was additional quality. When magnetic materials placed inside the magnetic field, all the dipoles are aligned in regular orientation. In the absence of magnetic field, all the dipoles are aligned in irregular orientation. So here, when placed inside the magnetic field, there was a regular manner. In the absence of field, there was an irregular manner. So those materials are called paramagnetic materials. So here susceptibility is small and positive. Susceptibility is small and positive for paramagnetic materials. So here, what are the examples for paramagnetic materials? Liquid oxygen and gaseous oxygen are the examples of paramagnetic materials. So which obeys Curie's law? J equals to C by T. J equals to C by T. So whereas coming to ferromagnetic materials. Ferromagnetic materials. So what is the additional quality of ferromagnetic materials? Even in the absence of magnetic field also, which acquires strong magnetization nature, those materials are called ferromagnetic materials. So which obeys Curie's law? J equals to C by T minus theta. So here theta is called theta suffix F. Ferromagnetic Curie temperature. So here below the particular temperature, the materials are called ferromagnetic Curie temperature. So above the ferromagnetic Curie temperature, the material becomes paramagnetic materials. So examples: iron, nickel, cobalt, gadolinium. These are the examples of ferromagnetic materials. Next one is hysteresis curve. So here I have drawn B versus H. So H can be taken on x-axis and B can be taken on y-axis. Means the lagging of magnetization behind the magnetic field is called hysteresis curve or BH curve. Hysteresis curve or BH curve. So here what happens in the hysteresis curve? If the field intensity increases, the flux density increases and reaches to maximum. This particular point is called saturation magnetization. So if the field intensity decreases in the reverse direction, then it reaches retentivity. It reaches retentivity. Further, the magnetic field reduced in the opposite direction, then the flux density reaches to 0 and the particular field is called coercivity. The particular area is called coercivity. So here again the field intensity increases in the opposite direction and reaches to maximum value, which is called saturation magnetization in the opposite direction also. So here the complete loop happens in the hysteresis curve or BH curve. So we can get saturation magnetization, retentivity and coercivity. Yes, next one is soft and hard magnetic materials. What are the differences between soft and hard magnetic materials? Soft magnetic materials and hard magnetic materials. So what is the difference? So for soft magnetic materials, which can be easily magnetized and demagnetized, So those materials are called soft magnetic materials. So what are hard magnetic materials? The materials which cannot be easily magnetized and demagnetized. Those materials are called hard magnetic materials. So here hysteresis loop is low. Here hysteresis loop is high. So that hysteresis loss is less. Here hysteresis loss is more. Hysteresis loss is more or high value. So here hysteresis loop is low. So that coercivity and retentivity are less. Here coercivity and retentivity are large. So that magnetic susceptibility and permeability are small. Here susceptibility and permeability are large. So here we can use soft materials are electromagnets. Soft materials can be used as electromagnets. So here another difference is electromagnets. Whereas coming to hard magnetic materials can be used as permanent magnets. So what are the examples? Iron, silicon, alloys. Here iron, silicon, aluminum, alloys are the examples of hard magnetic materials. So in part 1 video I have discussed all the nature of the magnetic materials, properties of the magnetic materials, and also classification, origin of magnetic moment, hysteresis curve, and soft and hard magnetic materials. So everybody has listened my part 1 video. So everybody, I hope everyone should watch this video. Please like, share and subscribe my channel.